So in this video we're going to show the entire workflow from start to finish, from freezing a sample and then putting it in the microscope and setting up a data collection. Now the purpose of this video is not to explain in detail what happens, because those are recorded in other videos, but the purpose is to show from step to step. So for instance, we start with preparing the ethane, we here freeze our samples, then we mount the samples in cartridges, we could put the cartridges in a cassette, and then we move the cassette over to the microscope. Now the reason for showing this entire workflow is to put the individual videos that go into more detail into the context and where to place them in the daily workflow. Now the best would be to finish this workflow from start to finish, from preparing your samples, freezing them, mounting them, putting them in the microscope and collecting data in one go. And the reason for that is that with every station, when you move from one station to the other, there's always a chance of picking up contamination. And imaging fresh samples is always better than imaging stored samples, because there might be something happening in storage. However, at each individual station there is a point where you can stop and actually store your sample for a later time to image. We're going to show this. Let's say you have reserved the microscope for one day and you have your samples ready and you have the microscope ready. So I'm going to show now how long it takes to go from sample to the start of data collection in one efficient way. Now let's start the workflow at the beginning, and this is at the glow discharge. So we'll move over to the glow discharge unit. So we're now at the glow discharge station, and I will pick 4 grids that I want to prepare, and I'm going to glow discharge them. These are my 4 grids. And start. So now that this is glow discharging, we can move over to the lab and prepare our liquid ethane. So we're now at the station of preparing our liquid ethane. We have our ethane bottle and we have our tray already set up. And we start with cooling the tray down with liquid nitrogen. And then we start by taking liquid nitrogen and filling the outside of the tray. So we can also fill here on the outermost side, especially when you have ethane being formed in the center. You don't want to pour any more liquid nitrogen in the center, because you run the risk of pouring liquid nitrogen straight into the liquid ethane, which then again has a splashing hazard but also solidifies. Now what you have to look for now is the heavy bubbling, and especially listen to the sound. I always pour some nitrogen in the center cup and now look at the heavy bubbling. We're still in the phase where we have the Leidenfrost effect, and that means that there is an insulating layer of gas that is between the liquid nitrogen and the surface. And we have to wait until that gas layer is disappearing, and that happens when the surface has the same temperature as the surrounding liquid nitrogen. And you can clearly see that by a sudden heavy boiling, but you can also hear it coming. So we now have a microphone very close to the center so you can hear it. And this is true for any part that you want to cool down with liquid nitrogen. You always have to wait until you see this heavy boiling and you hear this hissing sound, which is the Leidenfrost effect, when all the vapor that protects the surface between the liquid nitrogen and the surface instantly disappears all at once. So we still see that the liquid nitrogen is boiling, and that means that the central brass cup still isn't at the temperature of liquid nitrogen, which is minus 196 degrees Celsius. And I will keep pouring a little bit of liquid nitrogen in the center to speed this process up. But you have to be aware that at the end, when you're getting very close to this Leidenfrost effect, you don't want to fill up the entire cup, because then you're left with a lot of liquid nitrogen in the center, in which you cannot make liquid ethane. So if you would blow ethane gas into that liquid nitrogen, it would solidify. So now you hear the effect coming. Okay, that was it. So you saw that was a sudden heavy boiling and a hissing sound. And if you now look at the center, there's still a small layer of liquid nitrogen there, but it doesn't bubble anymore. So that means that the central cup in which we put the ethane vapor has the same temperature as its surroundings, so is at liquid nitrogen temperature. We can now start making our liquid ethane. And we do this by taking the nozzle coming from the bottle, and we're now going to open the flow regulator, and we do so by putting the tip of this nozzle inside completely down at the edge, and then we slowly open. And also here you have to use your ears until you hear this sound. This sound is indicative of a liquid that is being slowly blown, or a gas that is being slowly blown into a small layer of liquid. So that means at the bottom we have some liquid ethane that is formed. And we keep the tip of the nozzle pressed to the edge of the cup. And since the ethane is a very dense vapor, in the beginning you only have your ears. So now that this vapor disappears, you can actually start to see that there is some ethane. And I actually go a little bit up and down with the nozzle, especially in the beginning when there is a small layer of liquid nitrogen still present. You run the risk that the first ethane that comes out solidifies and blocks your tip. So you have to go a little bit up and down to make sure that this solid ethane is not formed and not blocking the tip. And once you have a layer of liquid ethane, you can slowly lift the tip, and you can actually hear when you're reaching the surface, which is there. When you're out, you hear the hissing sound of gas, and when you're in, you hear this liquid. And you can now slowly increase the flow to fill up the ethane a bit more quicker once you have a layer of ethane being formed. And by lifting the nozzle slowly up together with the rising liquid ethane level, you get a feeling how full the cup already is. And we have to fill this cup all the way up to the bottom part of the spider. So don't fill it all the way to the top of the spider, because then you run the risk that the spider gets frozen solid to the ethane cup. And you can start seeing bubbles at the edge to also give you an indication where the top level of the ethane is. And I'm using these bubbles, so I'm keeping the nozzle slightly under the surface of the liquid ethane. And the moment these bubbles are hitting the cooling spider, that's when there is enough liquid ethane present in the center. And when you reach the surface, it's good practice to reduce the flow again. You have to be aware that when you close the flow of ethane and this tip is still in your liquid ethane all the way down, the ethane will be sucked into your pipette via capillary force, which is something you don't want. So when you're close to the end, which is now, bring the flow back. You can use your ears again, and then with a little bit of flow take the nozzle out and then close the valve. So now you can see that the bubbles are almost touching the spider. So now we're almost full. I again reduce the flow, and I'm now going to take the nozzle out with a little bit of flow still coming out to prevent the ethane from coming back into my pipette with capillary force, and then I'll close it completely. So that's it. So now we have a filled cup, and we have to wait until this is cooled down enough. So we can add a little bit of liquid nitrogen, but now add the liquid nitrogen only to the outside. Don't pour it inside. Also be aware that when you pour, you can also pour nitrogen vapor, which is cold as well. So if you want to make sure that this central part is clean, you can actually pour, like you can see here, you can pour nitrogen vapor on the inside, and you can pour liquid nitrogen to raise the level on the outside. So be aware that this ring now creates a nitrogen atmosphere around the center of the cup. So this is also a protective atmosphere that makes sure there is not a lot of contamination coming to the center. And you can see here that the level of ethane is at the lower side, so there of the spider. So it's not to the top, but it's to the bottom. And what you have to look for now is the creation of solid ethane. Ethane turns liquid at -80. So the temperature, the boiling temperature basically of ethane is -80 degrees. So that's where ethane turns from a gas into a liquid. If we would plunge freeze in freshly made liquid ethane, the temperature would be -80. Now the devitrification temperature of water is about -150 degrees C. That means that the ethane, when it's just made, is too warm for water to be vitrified. So if we would plunge freeze with freshly made liquid ethane, we will get crystalline ice. And that's what we like to avoid. We want to have vitreous ice. So therefore the temperature has to be colder than -150 degrees Celsius. We can see that by waiting for the ethane to solidify. So as long as these spider legs are cooling the center, the temperature, the conduction temperature, is still that of liquid nitrogen, -196 degrees. The temperature at which ethane solidifies is -180, which is cold enough to freeze. So what you have to look for is now you can already start to see a small white edge, and that is the liquid ethane turning solid. Also at the bottom you can now start to see that it turns white. So ethane is now at the melting temperature, and that is at minus 180. Now we can use now a pair of pliers to pull this spider off because it's frozen solid to the top. There's also a trick. We can take a second brass cup, place it on the top and heat a little bit that spider, and then we can very easily take it off. So there we have it. We now have an insulated cup with liquid ethane inside, and you see that the edge is solidified. So this is liquid ethane at its melting temperature at minus 180 degrees Celsius. So we can now move our freshly prepared ethane over to the Vitrobot where we can start preparing our specimens. So we'll take our nitrogen, grab a chair, so I'm taking a pipette. I have my sample over here. We can now start preparing our specimens. So I'll set the Vitrobot to 100% humidity, switch on. You can see that the vapor is going into the chamber. I'm gonna set it the way I like to freeze. Gonna set my right blot force and the blot time. So I now need my grids, so I go to the glow starts and pick the grids up. So I'm now freezing the first grid. Placing the ethane. Taking some of my sample, applying the sample, blot, and freeze. Pouring the vapor into the center, not nitrogen, I'm pouring vapor to clean out the center so I can see what I'm doing. And I'm adding nitrogen at the outside. I'm now gonna unlock these tweezers and bring this to the side. Now we're going to remove the clamp, and I place the grid into the storage box. Remember to already have a storage box in there. And I'm now warming up the tip of these tweezers with my fingers and wiping it down so that it's not wet. And I'll freeze the second grid. I can decide to change the blot settings for screening or have the same blotting several times in a row to see if we can have a good reproducibility. I'm now changing the blot settings for screening of different blot parameters. Next grid. Again, some liquid. Apply. Blot. Pouring vapor again in the center. And I see the nitrogen level has gone down a little bit. So some nitrogen on the outside. Again, unlock it. Remove the clamp. And place it in the next slot of the storage container. I can now start freezing grid number 3. So I'm again adjusting the blot parameters. Getting the third grid now. Apply. Blot and freeze. Again, I'm pouring vapor on the inside, a bit of nitrogen on the outside. Unlock, support, move over, unclamp and place in the storage box. The final grid, I'm again changing blot settings. It's also good that you store or write down somewhere the different types of blot settings that you're using, especially when you're screening, that you remember which grid goes where in the cassette, so you can find out which blot settings works best for you or for that particular sample. The fourth, last sample. Into the chamber, ethane, last specimen, apply, blot, pour vapor, pour liquid, moves to the side, unclamp and store. Okay. So we now have 4 grids frozen. We can decide to put a lid on that box. This lid is coated with aluminum foil. The reason for it is that grids do not stick anymore to the lid when you do that. So we can now put a lid on that and place this into storage. So this is the first point where you can stop and store your samples. We're now going to continue. So I'm not going to put a lid on it. I'm going to make sure that there is enough liquid nitrogen here in the tray that these grids are submerged on the liquid nitrogen, and also the floating ring makes sure there's a nitrogen atmosphere here. So your grids will be perfectly free of contamination while they're sitting here. We're now moving over from the grids that we have frozen, and we now want to mount them in autogrid cartridges. So we move over to the next station, which is here. Well, let's take these prepared grids also to that station. And we're now starting to freeze or to mount our grids in autogrid cartridges, and for that we have to cool down this station. So let's start. And we add nitrogen in here. Place the cover on it. And you'll notice I often spill quite some nitrogen, because that also is cleaner. When there is a lot of nitrogen vapor around, there cannot be any water vapor. While this is cooling down, I can prepare my C-clip tools. So I'm going to place the springs, the C-clip spring, into these tools. And the last one I'm going to do 4. Okay, so these I now have pre-prepared. This station is not yet cooled down, and I'm pouring nitrogen only on the outside. Saving time, I could already pre-cool these tools by placing them in here, because they're then cooled by vapor, like so. We have to wait now for this to cool down. Also make sure you check up on your storage where the grids are, that there's enough nitrogen in there as well. And now that it's cooled down, we can place the storage box for the autogrid cartridges in here. We can also place our autoloader tweezers, and we can cool the tweezers with which we will grab our grids from the box. And we have another pair of dry tweezers for the autogrid rings that we place there. We now have to transfer our freshly plunge frozen grids from here to there. You pre-cool it on the side in the liquid nitrogen, and again you know that when it's cold, when the light and frost effect has stopped, so when the sizzling is over, then the lid is cooled enough, and then you place it on the storage box, you turn it and screw the lid on. So we now move this box from here to the workstation in one move, and then we place it. Okay. This can go over to the side. Now we can start mounting our freshly made grids into autogrid rings. So we place one of the rings here. So we're going to take one of these grids out and place them on the ring. Be aware, these grids can get stuck to your tweezers, they can jump around, they can move, but try to grab them as farther to the edge as possible, because the more contact you have with these grids, the easier it is for them to get stuck to your tweezers and move around. And we can center the ring, centering disc over our grid. Now we come with our pre-prepared insertion tool. Just dip them, only the tip, in liquid nitrogen and wait until you see again the light and frost effect. So now we are putting the insertion tool on top, and we slowly click. You can now turn the disc back, and we can take our autogrid assembly cartridge out of the slot, place it in the storage box, and we will now repeat that 4 times for the other grids. So that's placing a ring, placing our plunge frozen grid, turning the alignment disc on top of it, cooling our tool, click, turning the disc back, and placing our second grid in the storage box. Let's do it for the fourth or the third grid. Turning the disc, pre-cooling our tool in the liquid nitrogen, click, it's grid number 3, and the last one. Click. Okay, so this is 4 grids done. This is a bit contaminated, so I'll warm it up. And we can now put a storage lid, cool it down, wait for the bubbling to stop. So now we know the temperature of the lid is at liquid nitrogen temperature. And we then turn and we put the lid on, like so. Move it to the nitrogen again, which is where we can store it for the next step. So now again you're at a state where you can take that storage box and either store it in liquid nitrogen, or we move to the next step as we take the storage box to the station and load them into the cassettes. So let's now do that step. We go from here and load these grids into an autoloader cassette. So we'll take the whole station, which has our cartridges inside. We take our tool, and we now need to cool down this station and put a new cassette in there. So we have a fresh cassette which doesn't have any grids in it. So we make sure that we orient it in the right way, and we can place it here in the station, the workstation. And we have an empty capsule. This is dry, and we can mount that one, so that we can now cool the whole station as a whole with liquid nitrogen. So I'm pouring liquid nitrogen into the capsule and into the loading station. As you can also see, this whole process, every individual step requires quite some liquid nitrogen. So now I'm keeping all the covers off because I'm cooling down both the capsule and the workstation at the same time. When all the heavy boiling has stopped, that is an indication that the station is cold, and we can start mounting our grids. So we can now mount our grids, our auto-grid cartridges, into the cassette. So we can take our storage box from a different storage, or now from the cartridge mounting tool, into the loading station. And you can place the storage box with the auto-grid cartridges into one of the slots. I always use a slot closest to the cassette, and then we unscrew the lid from the storage box. Be aware the lid might get stuck. The next thing is we take our auto loader tweezers and cool them down. And we might also need a pair of standard tweezers. We can cool them down as well. And again, you want to wait for the Leidenfrost effect. So when the hissing sound is over and the boiling stops, the tweezers are cold enough so you can grab the grids. So we can now start loading our grids into the cassette, and we now, with the tweezers straight, so that's one, and we turn it around and we tap it, because some of the clarity in your vision will be obscured by the vapor of the nitrogen. So I'm holding now the grid box down with a pair of tweezers. So all three grids have now been loaded. And I'm checking these grids by tapping them down in their respective slots. We can now refill with some liquid nitrogen, and we also refill the capsule a little bit with some liquid nitrogen. And you may spill here. The more nitrogen vapor you spill, the cleaner you will work, because this will expel all the water vapor. And we then take the handle, slide it over the cassette, grab the cassette by pushing the pin, and then into the capsule. We check the pin, put a lid on. Now we can go to the microscope. So coming at the microscope, we open the door. We again check if this pin is moving and not frozen. And then we place it and just push it to the back. And now we press on the interface, we press dock. And then the capsule is docked. So first it vents the loader, so that it can open the valve. In the loader there's vacuum, so it will break the vacuum and vent the loader. It will then bring the arm down now and get the cassette from the capsule. And now raises the arm back up. Closes the valves and starts up the turbo and releases the capsule. So now that the cassette has been docked, you can take the capsule out. You can look that there is no cassette in there, so we know it's in the loader. We now move over and we can place the capsule to dry into one of the dry stoves. And we can go over to the microscope. And we can now start screening when the vacuum is restored.